called applying what we know. So what we're going to do is we're going to do problem solving stuff. So we've got a triangle right here, and they want us to find the exact length of xy. So I'm trying to find that. Now, exact length means leave it as an answer in a radical simplest form. And what that is that means it wants a mixed radical. So the first thing we have to do is calculate it using Pythagorean theorem. And Pythagorean theorem is always a squared plus b squared equals c squared. Now remember, a and b are the legs of our triangle. So the legs meaning they are attached to the 90-degree side. The hypotenuse, what we're looking for, is always c. It's the longest side always. So what we're going to do now is we are going to put it into the equation. So I want xy, and that's going to be equal to, well, xy squared, I should say, because my c squared. It's going to be equal to 4 squared plus 8 squared. So xy squared is equal to 16 plus 64. Xy squared is equal to 80. Now, how do I get rid of that squared sign? You square root, good. So I'm going to square root both sides now. And when I square root both sides, these are opposite functions. So what happens is they cancel each other out. So I get xy equals root 80. So that's my entire radical, that's A. Now the next step for B is to break root 80 down into a mixed radical. Okay, I'll give you a couple minutes to finish writing that down. Okay, so we found our entire radical was root 80. Now we're going to break that down for our mixed radical. So if I take root 80, I can go 4 times 20, correct? Okay, we know there's larger ones, but let's start with 4 and 20. So we're going to have root 4 times root 20. The root of 4 is how big? 2, good. So we're going to stick it beside root 20. And now I'm still going to break root 20 down. So 2 root 20 can break down into root 4 and root 5. Don't forget our 2 that's already out front, so he's going to be attached to our perfect square that comes out. And now I take my perfect square as well. So my final answer will be 2 times the extra 2 coming out from the root 4, all times root 5. I combine my coefficients, I multiply the 2 and the 2, and I'm going to get 4 root 5. Okay, last step, we're just going to take the decimals, so take root 80, and we're going to find it in our calculator, and we want 2 decimal places, so 8.94. Okay? Moving on to the next question on the bottom of the page. We've got another question that's exactly like the one we just did, only there's 2 triangles combined now. The letter D down here is missing. So, you should write the letter D in. So this question is asking us to find A to B. Well, A to B, we can't find him until we find the A to D. I need a number there. How come? Because I've got 2 triangles attached. They share that leg, they share that side. And over here on this triangle, I only have 1 number. You always need 2 out of 3 numbers to solve the other unknown. So that means I have to solve for this side first, the A to D, so that I have a number there to use with the 4. Okay, is everybody with me so far? Yep? Yes. Okay, so now what we're going to do is we're going to find A to D. Now we're going to use the Pythagorean theorem again. Our a squared plus b squared equals c squared. But this time, we already have the long one. We have our long side. Okay, our long side being our hypotenuse, the 10. So since we have our long side, we need to subtract from the long side. So we're going to say A to D is equal to the root of 10 squared minus 6 squared. Okay, why did I put the root first? I'm just skipping a step for us. So instead of me putting AD squared equals 10 squared subtract 6 squared, and then square rooting is my final answer, I can do it all in one step. So I'm going to get A to D is equal to root of 100 minus 60 or 36. Now, radicals behave like brackets, which means solve underneath them before you take the radical of it, the root of it. So this is going to be AD is equal to the root of 64. And root 64 is a perfect square. How large is it? It's 8. Good. So that means it's 8.
The other triangle is only 2.
I know. So now it's going to turn into an 8. And now if we know, just like someone pointed out, this triangle, the red one now, it's exactly like the question we just did, an 8 and a 4. So what should our side up here equal? 8.94 or root 80, right? So on this question, I would just go 8 squared plus 4 squared, square root it, and that's going to give me root 80. And that's going to be my question mark there. Yes? Okay, so remembering that these triangles and drawings are never to scale. Always remember that this, even though it looks shorter, the numbers work out. So let's take a look now at area. We have an area of this square. We know area is equal to length times width. So when we've got a square and both sides are the same, we just say area is equal to our side squared. That's what we call area, okay, for a square. So since it's a square, I can put ticks on this, and I know they're all identical, they're the same size. So it says determine the square length. So we have a formula we use. If I want to know the side, if I want to know my side, I need to take the square root of the area. And that's all it is. It's just one step, square root of area. So you guys give that one a try, and then push pause right now. Push play again when you're ready for the answer. Okay, I'm taking the square root of 252. We do not want the decimal because it's asking us for simplest form. It wants an exact value answer, so you need to divide by a perfect square. So we divide by our perfect squares. We're going to find 36 times 7 works. So we break this guy. Oopsie, move him down for a moment. We are going to break him down into root 36 times root 7. So that's going to give us 6 root 7. So that's how long one side is 6 root 7. Okay? It's not asking me for a decimal answer. It's asking me for the simplest form. That tells me right away I have to leave it as a mixed radical. Okay? Any questions so far? Yes? So same type of thing we did in example 3. We had a squared, so we square rooted, did opposite function. Now we've got a cube that is cubed. We are going to cube root to find the side. So side is equal to the cube root of the volume. So I'm going to find the side by taking cube root of 81,000. Try that one for a moment. Push pause and push play when you're ready. Okay, so the first thing we're going to do is we're going to look at our perfect cube chart, and with 3 zeros, we're going to automatically see that it can divide out by 1,000. So we're going to say that this is equal to cube root of 1,000 times cube root of 81. Now the 1,000 breaks down into 10. The cube root of 1,000 is 10. And I bring my cube root 81 and it sits beside him. Now, cube root 81 can also be broken down again. He divides evenly by another perfect cube, which is 27. So now I bring him down, and I break him down further. So I'm going to have cube root 27 times cube root 3, and the 10, you can't forget him. He's attached in front of the other cube roots. Okay? So now the 10 still keeps coming down. The perfect cube of 27 is a 3. So he also comes down, and then I connect with my cube root 3 that's left over. Now the last step is to multiply my two coefficients, 3 times 10, to give me 30 to the cube root of 3. And that would be our final answer in simplest form. Okay, so when you stop here at 10 to the cube root 81, you have to keep going. It breaks down further. Now don't forget the common mistake is that this 10, a lot of you made him disappear. He can't disappear. He's attached to this cube root sign, so he keeps coming attached every time. Okay? Any questions so far? No, I think you're doing pretty good. All right, let's move on to the last one. Okay, we're gonna review the questions. We're now gonna take those up quickly. You should have this one looking like root 4 squared times 2, which will give us root 32. We're going to look at the next one, cube root 135. What can we break cube root 135 into? What does he divide by? 27 and 5. Good. So I've got cube root 27, don't forget your index, times cube root 5. That's going to give me 3, let's try that again. A big 3 to the cube root of 5. Okay? On the bottom, let's see if you figured these out. The index is the tiny number inside the check mark. The index is the 4. Our radicand is under the radical still. He is our 8. 5 is our coefficient. Co means in front. So the coefficient is a 5. Okay, that concludes our second half of 1A.